Imagine standing alone on a windswept cliff in what is now Gibraltar 40,000 years ago. You're the last one, the last of your kind. Your family is gone, your tribe scattered or dead. You've lived your entire life knowing others like you, hearing their voices, seeing their faces around the fire. But now there's only silence. You are a Neanderthal, and your species is about to vanish from the earth forever. Somewhere else on the planet, maybe just a few hundred miles away, another group is thriving. They look similar to you, but different. Taller, thinner, weaker looking. They're spreading across the landscape, multiplying, adapting. They are Homo sapiens, modern humans, and for reasons nobody fully understands, they're going to inherit the earth while you disappear into extinction. This is the central mystery we're going to explore tonight. Why did Neanderthals, our closest relatives, our cousins who survived for over 300,000 years through multiple ice ages and countless catastrophes, suddenly vanish? And why did we seemingly more fragile, apparently less adapted to the brutal ice age environment, survive and flourish? If you're using this to fall asleep, that's literally why I make it. So maybe subscribe and tell me where you are and what time it is. I check the comments and it's like Tokyo at sunrise, Toronto at midnight, all happening at once. For most of human history, we didn't even know Neanderthals had existed. Then, in 1856, workers in Germany's Neander Valley discovered a skull that would change everything. It was human-like, but wrong. The brow ridges were massive. The skull was elongated. The bones were incredibly thick and heavy. Scientists argued for decades about what it meant. Some thought it was just a deformed human. Others recognized it for what it was, evidence that we once shared this planet with another species of human. And here's what's truly mind-bending. They weren't primitive failures. They weren't evolutionary dead ends shambling toward extinction. Neanderthals had brains as large as ours, maybe larger. They controlled fire, created sophisticated tools, buried their dead with what appears to be ritual care. They survived in an environment so harsh that most modern humans would die within days. They were the apex predators of Ice Age Europe, perfectly adapted to one of the most hostile climates Earth has ever known. So why are they gone while we're here? That question has haunted anthropologists for over 150 years. And every time we think we've figured it out, every time we settle on a comfortable explanation, new discoveries blow our theories apart. For a long time, the story was simple. We were smarter. They were dumb brutes. We outcompeted them. End of story. Except that's not what the evidence shows. Not even close. The real story of Neanderthals is far stranger and more disturbing than anyone imagined. Their bodies were bizarre, built in ways that make no sense until you understand the extreme world they inhabited. Their behavior was a mixture of the familiar and the utterly alien, and their disappearance, when we finally piece together what actually happened, raises uncomfortable questions about our own ancestors and what they might have done. In the past decades, scientific breakthroughs have revolutionized everything we thought we knew about Neanderthals. We've sequenced their entire genome and discovered that most people alive today carry Neanderthal DNA in their cells. We've found evidence of art, music, medicine, and symbolic thinking that was supposed to be uniquely human. We've uncovered remains showing they cared for their sick and elderly, that they felt grief, that they might have even had language. The Neanderthals weren't the primitive cavemen of popular imagination. They were people. Different from us, yes. Strange in ways we're only beginning to understand, but people nonetheless. And somehow, despite everything they had going for them, Despite 300,000 years of successful survival, they vanished completely while we inherited the Earth. Tonight, we're going to explore the mystery of our lost cousins. We'll see exactly how strange they really were, both in body and mind. We'll walk through their Ice Age world, hunt with them, live with them, and we'll investigate what really happened when two species of humans collided in Europe 40,000 years ago. One encounter that changed the fate of the planet forever. Let's talk about Neanderthal bodies, because when you actually look at the anatomy, when you examine what these people were built like, you realize something extraordinary. They weren't just slightly different versions of us. They were built like nothing else that has ever walked this planet. Start with the chest. A Neanderthal's rib cage was massive, barrel-shaped, expanding outward in a way that would look almost comical on a modern human frame. But this wasn't some random quirk of evolution. That enormous chest cavity housed lungs that were substantially larger than ours. We're talking about respiratory capacity that exceeded modern humans by potentially 20 to 30%. Think about what that means. Every breath a Neanderthal took pulled in more oxygen than you or I could manage. Their cardiovascular systems were pumping oxygen to muscles and organs at rates we can barely imagine. This wasn't just helpful in the thin, cold air of Ice Age Europe. This was a fundamental reimagining of human respiratory physiology. They were breathing machines, perfectly calibrated for environments where every calorie mattered and every breath of frigid air needed to be processed efficiently. But the chest was just the beginning. Look at the bones themselves. Neanderthal skeletons show bone density that makes modern human bones look fragile by comparison. When anthropologists first started analyzing Neanderthal remains using modern scanning technology, they found bone mineral density readings that were off the charts. These weren't just thick bones. These were bones that had been subjected to extraordinary mechanical stress throughout life. Bones that had adapted by becoming denser, stronger, more resistant to fracture. And the muscle attachment points. This is where things get really wild. Bones preserve marks where muscles and tendons attach during life. The bigger the attachment point, the bigger and stronger the muscle. Neanderthal bones show attachment points that would make professional athletes jealous. Their arm bones, their leg bones, their shoulder blades, everything shows evidence of muscle development that we struggle to find even in modern powerlifters. Researchers have tried to estimate Neanderthal strength based on these skeletal markers. The conservative estimates suggest they were perhaps 20 to 30% stronger than modern humans. The more aggressive estimates, based on biomechanical modelling of their skeletal structure, suggest they might have been 40 to 50% stronger. Some researchers think even those numbers are too low. Picture this. An average Neanderthal, male or female, could probably have snapped a modern human's arm bone with their bare hands. Not because they were giants, they weren't particularly tall, but because their muscle mass, their bone density, their entire skeletal structure was built for generating force in ways our bodies simply aren't. Then there's the skull. You've probably seen reconstructions, those distinctive faces with the heavy brow ridges and the sloping foreheads. But pictures don't really capture how different a Neanderthal skull actually was. The brow ridge wasn't just prominent, it was a solid bar of bone extending across the entire forehead, creating deeply recessed eye sockets that would have given Neanderthals a distinctly shadowed, intense gaze. Behind that brow ridge, the skull extended backward in an elongated shape that's completely unlike modern human cranial morphology, where we have rounded skulls that sit neatly above our spines. Neanderthals had skulls that projected backward, requiring massive neck muscles to support the weight, and those neck muscles left their marks, deep grooves and ridges on the back of the skull where tendons anchored to bone. But here's what's really strange. Despite having this elongated, archaic-looking skull shape, they had bigger brains than we do. Modern human brains average about 1,350 cubic centimeters. Neanderthal brains regularly exceeded 1,500 cubic centimeters, with some individuals reaching 1,700 or even 1,800. They had the largest brains of any human species that ever lived, housed in skulls that looked primitively compared to ours. Of course, brain size isn't everything. The shape matters too, and Neanderthal brains were shaped differently than ours. Modern humans have high, rounded skulls with enlarged frontal lobes, the parts of the brain associated with planning, abstract reasoning, and social cognition. Neanderthals had flatter skulls with proportionally larger occipital lobes, the visual processing centers at the back of the brain. What does this mean? Maybe their brains were optimized differently. Maybe they had enhanced visual processing capabilities, better spatial reasoning, superior ability to navigate and remember complex landscapes. Or maybe the shape differences don't mean much at all, and they were just as cognitively capable as modern humans despite arranging their neurons differently. We're still figuring it out. And then there's the face itself. No chin. Modern humans have these distinctive bony projections at the front of our lower jaws. Neanderthals didn't. Their jaws sloped backward, giving them a profile that would look distinctly alien to modern eyes. But they made up for the lack of chin with something else. Noses, enormous noses. Neanderthal nasal apertures, the holes in the skull where the nose attaches, were huge, substantially larger than modern human nasal openings, and CT scans of Neanderthal skulls reveal internal nasal cavities that were extraordinarily complex and spacious. These weren't just big noses, these were sophisticated climate control systems. The leading theory is that those massive nasal passages were adaptations for breathing Arctic air. When you breathe in frigid, dry air, your body has to warm it and humidify it before it reaches your lungs. Otherwise, you damage delicate lung tissue and lose dangerous amounts of moisture through respiration. Modern humans do this, but our relatively small noses struggle in extreme cold. Spend time in -20-degree weather and you'll feel it, that burning sensation in your nose and lungs, the way breathing becomes uncomfortable. Neanderthals solved this problem through raw anatomical real estate. Those enormous nasal passages gave them more surface area, more space for warming and moisturizing air before it reached their lungs. Combined with their massive lung capacity, this would have made them far more efficient at surviving in the brutal cold of Ice Age Europe. Some researchers think the large noses served another function too: thermoregulation. All those blood vessels in the nose radiating heat, helping to cool the brain during intense physical activity. When you're built like a Neanderthal, when you're carrying that much muscle mass and generating that much body heat, even in freezing temperatures, brain cooling becomes a serious concern. That big nose might have been acting like a radiator, protecting their oversized brains from overheating during mammoth hunts and other strenuous activities. But perhaps the strangest thing about Neanderthal anatomy wasn't visible on the skeleton at all. We know this from DNA analysis of Neanderthal remains. Many of them had red hair, not the brownish red you sometimes see in modern humans, but true red, hair caused by variants in the MC1R gene that are different from the variants that cause red hair in modern humans. They evolved red hair independently, through a completely different genetic pathway. And that red hair probably came with pale skin and freckles, the whole package of traits associated with reduced melanin production. This makes perfect sense for people living in the low-light conditions of Ice Age Europe, where darker skin would have made it harder to synthesize vitamin D from the limited sunlight. But it means many Neanderthals would have looked strikingly distinctive, pale-skinned, red-haired, massively built individuals with faces dominated by those enormous noses and heavy brow ridges. Then there's the build. Neanderthals were stocky, compressed versions of modern humans. Where we have long legs relative to our torsos, adaptations for efficient long-distance travel in warm climates, Neanderthals had short legs and long torsos. This compact build reduced surface area relative to body mass, minimizing heat loss in cold environments. It's the same principle you see in modern cold-adapted populations, Inuit people, Sami populations in Scandinavia, but taken to an extreme. An average Neanderthal male stood maybe 5'5" tall, but weighed as much as or more than a modern 6-foot man. That weight was distributed differently though, less height, more mass, creating a body shape that would have been extraordinarily powerful, but perhaps less efficient for long-distance running. They were built for power, not endurance, for generating massive force in short bursts rather than covering vast distances. Recent studies of Neanderthal inner ear structures have revealed something else strange. The semicircular canals, the parts of the inner ear responsible for balance and spatial orientation, were shaped differently than in modern humans. They were larger, more robust, oriented at slightly different angles. What this means for their actual movement patterns is still being debated. Some researchers think it might have affected their agility, their ability to make quick directional changes. Others think it might have enhanced their ability to maintain balance on rough terrain or while throwing spears with tremendous force. There's also evidence that Neanderthal limb proportions affected their throwing mechanics. Modern humans are exceptional throwers, possibly the best in the animal kingdom. Our shoulder joints, our arm lengths, our ability to store and release elastic energy makes us capable of hurling projectiles with devastating accuracy and power. Neanderthals had different shoulder joints, different arm proportions. They could throw, the archaeological evidence proves it, but they probably threw differently than we do. Maybe with more of an overhand stabbing motion rather than the sidearm throws modern humans favour. All these anatomical differences add up to something profound. Neanderthals weren't just cold-adapted modern humans. They were fundamentally different animals built for a world and a lifestyle that required capabilities modern humans simply don't possess. If you could somehow bring a Neanderthal into the present, if you could stand one next to a modern human, the differences would be immediately obvious. Not just in the face, though, that would be striking enough, but in the entire build, the proportions, the way they moved and carried themselves. They would look powerful, dense, built for strength in a way that even our strongest athletes can't quite match. But here's what's really haunting about all these anatomical details. Despite being so different, despite these bodies that were optimized for a world we can barely imagine, they were still human, still close enough to our ancestors that when the two species met, they could interbreed and produce fertile offspring. Still close enough that they shared our capacity for language, art, symbolic thinking. They were us, but different. Strange cousins shaped by hundreds of thousands of years of evolution in the harshest environments Europe had to offer, and their bizarre bodies, perfectly adapted as they were, weren't enough to save them from extinction. But that's getting ahead of the story. First, we need to understand the world those bodies were built for, the strange frozen landscape of Ice Age Europe, where Neanderthals became the dominant predators for hundreds of thousands of years. Picture this, It's 50,000 years ago, and you're standing in what will one day be southern France. But nothing about this landscape resembles the France you know. There are no vineyards, no rolling green hills, no quaint villages. Instead, you're looking at a vast grassland steppe stretching to the horizon. Cold, windswept, dotted with patches of stunted pine and birch trees that somehow survive winters that last 8 months. The temperature is 15 degrees colder than today. Ice sheets thousands of feet thick cover Scandinavia and much of northern Europe. And walking across this landscape are creatures that seem impossible, like something out of a fever dream. A woolly mammoth, 13 feet tall at the shoulder, covered in shaggy reddish-brown hair, its massive curved tusks scraping the ground as it searches for grass beneath the snow. A woolly rhinoceros, equally massive, equally hairy, its horn longer than your arm. Giant cave bears that weigh twice as much as modern grizzlies. Cave lions bigger than any lion alive today. And somewhere in this landscape, watching these animals, planning, calculating, are the Neanderthals. This was their world. Not occasionally, not as a phase they endured, but for hundreds of thousands of years. This frozen grassland, this megafauna park, this was home. And they weren't just surviving here, they were thriving. They had adapted to this environment so completely, so thoroughly, that they became its apex predators. But here's what's wild. Everything we thought we knew about how they lived, most of it is wrong. The classic image of the Neanderthal, the one that's been burned into popular culture for over a century, shows them huddled in dark caves, barely surviving, waiting out the Ice Age in primitive shelters, while more advanced humans developed civilization in warmer climates. It's a compelling image. It's also mostly fantasy. The truth is far stranger and far more impressive. Yes, Neanderthals used caves. Archaeological evidence proves that. But they weren't cave dwellers in the way we imagine. They didn't spend their lives cowering in the dark, scared of the outside world. They used caves the way modern humans might use a cabin or a seasonal camp. A place to shelter during the worst weather, a refuge when you need it, but not a permanent home. The majority of Neanderthal sites that archaeologists have discovered are open-air camps, temporary settlements on river terraces, in valley bottoms, on hillsides with good views of game migration routes. These weren't crude sleeping spots. Many show evidence of sophisticated construction. Windbreaks made from branches and animal hides. Hearths carefully positioned to maximize heat distribution. Tool-making areas separate from sleeping areas, showing they understood the importance of camp organization. Some sites show evidence of structures that would have required days of work to build. Circular arrangements of mammoth bones and tusks, probably used as foundations for tent-like shelters. These weren't emergency camps thrown together in an afternoon. These were planned construction projects, the work of people who understood engineering principles and expected to use these shelters repeatedly over multiple seasons. And they moved. A lot. Analysis of stone tool raw materials shows that Neanderthal groups regularly travelled circuits covering dozens of miles, following seasonal resources, tracking animal migrations, exploiting different food sources as they became available. They knew their territories intimately, every water source, every good hunting spot, every place where flint or other tool-making materials could be found. But here's where it gets really intense. What were they hunting? Because this is where the Neanderthal story becomes almost unbelievable. We're not talking about hunting rabbits or deer or other small game, though they certainly did that too. We're talking about regularly, systematically hunting animals that could kill you with a casual swipe of a horn or tusk. animals that weigh several tons, animals that modern humans would consider suicidally dangerous to approach with anything less than high-powered rifles. The archaeological evidence is unambiguous. Neanderthal sites are full of the bones of woolly mammoths, woolly rhinos, bison, wild horses and reindeer. And these aren't scavenged bones. The butchery marks, the way the bones are broken to extract marrow, the stone tools embedded in vertebrae and ribs, all of it points to hunting. Active, deliberate hunting of the largest animals in Ice Age Europe. Now think about what this means. A woolly mammoth is 13 feet tall and weighs 10 tons. Its tusks are lethal weapons that can impale a human with zero effort. Its trunk can grab and throw a grown man like a rag doll. And Neanderthals hunted them with spears, not thrown spears, not spears launched from a safe distance with an atlatl or bow. Thrusting spears, weapons you have to use at close range, weapons that require you to get within a few feet of an animal that can kill you instantly. This is insane. This is the most dangerous form of hunting imaginable, and they did it successfully enough that mammoth remains show up at Neanderthal sites across Europe. They weren't getting lucky occasionally. They were hunting megafauna as a regular part of their subsistence strategy. How do we know it was dangerous? Because their skeletons tell the story. Neanderthal remains show an injury pattern that's basically unique among early human species. Healed fractures, crushed bones, broken ribs, damaged vertebrae. The frequency and distribution of these injuries match only one modern occupation: professional rodeo riders, people who work with large, dangerous animals at close range. Let that sink in. Neanderthals lived their entire lives with an injury risk equivalent to modern rodeo professionals. But rodeo riders have backup. They have medical care, safety equipment, other riders ready to help if something goes wrong. Neanderthals had none of that. A major injury, a broken leg, a crushed pelvis, that could be a death sentence. And yet the archaeological record shows many Neanderthals survived horrific injuries, healed, and kept hunting. There's a famous Neanderthal skeleton from Shanidar Cave in Iraq that shows exactly what this lifestyle meant. This individual had survived multiple major injuries. A crushing blow to the left side of his face that probably left him blind in one eye. A withered right arm, possibly from an injury or infection in childhood. Severe arthritis throughout his skeleton. And he lived with these disabilities for years. His bones show he reached his 40s, which was ancient by Neanderthal standards. What does that tell us? It tells us that Neanderthal groups cared for their injured and disabled. Someone with those injuries couldn't hunt mammoth, couldn't contribute to the most dangerous and important tasks, but his group kept him alive anyway, fed him, protected him, valued him enough to let him live despite his inability to contribute to the hunt. That's not primitive. That's sophisticated social behavior. But there's a flip side to this story. Because while Neanderthals were clearly capable of impressive cooperation within their groups, those groups were small, really small. Analysis of archaeological site distributions suggests most Neanderthal groups consisted of maybe 20 to 30 individuals. Extended family units, parents, children, maybe cousins and grandparents. That's it. And these groups were isolated. Territorial ranges reconstructed from toolstone sources suggest most Neanderthal groups rarely travelled more than 30 to 50 miles from their home base. They knew their territory intimately, but they didn't travel far beyond it. They didn't maintain the kind of long-distance trade networks that would later characterize modern human societies. Genetic analysis confirms this isolation. Neanderthal DNA shows patterns consistent with small, relatively isolated breeding populations. Inbreeding was common, not because they preferred it, but because there simply weren't many potential mates available. If you lived in a group of 25 people in southern France, and the nearest other Neanderthal group was 100 miles away across difficult terrain, your mating options were extremely limited. This created vulnerabilities. Small populations are fragile. One bad winter, one disease outbreak, one string of hunting accidents, and an entire group could disappear. And with groups isolated from each other, there was limited opportunity for survivors to integrate into other communities. When a group went extinct, their knowledge, their specific adaptations to their territory, all of that could be lost. Compare this to what we know about early modern human hunter-gatherers. They maintained contact networks spanning hundreds of miles. They traded goods, exchanged information, and most importantly, exchanged mates to prevent inbreeding. When one group faced difficulties, they could call on allies for help. When resources failed in one area, they could relocate to territories where their cousins or trading partners could support them. Neanderthals seem to have lacked these extended networks. They were survivors, fighters, incredibly tough and resourceful. But they were also isolated in ways that would prove catastrophic when conditions changed. Now, let's talk about fire, because the Neanderthal relationship with fire reveals something profound about their capabilities and their limitations. For decades, archaeologists debated whether Neanderthals could even make fire. Some sites showed evidence of controlled fires, but were they lighting them or just maintaining fires started by lightning strikes? Recent discoveries have settled this debate. Neanderthals absolutely knew how to make fire. Archaeological sites show patterns of fire use that would be impossible with naturally occurring fires. Hearths, in locations where lightning couldn't reach. Multiple fires in the same location over months or years. Evidence of fire being transported between sites. And most tellingly, traces of manganese dioxide and iron pyrite. Minerals that can be used to create sparks for fire starting. They used fire extensively and skillfully. Hearths weren't just for warmth and cooking. They were the centre of Neanderthal social life. Archaeological sites show that tool-making, food processing, and social activities all clustered around hearths. Fire provided light during the long winter nights. It kept predators away. It made tough meat digestible and some toxic plants safe to eat. It was fundamental to their survival. But here's what's interesting. Neanderthal fire use was conservative. They used it for essential purposes: warmth, cooking, light. But there's limited evidence they experimented with fire in the way later humans would. No evidence of pottery making, which requires very hot, carefully controlled fires. No clear evidence of using fire to harden wooden tools or process resin adhesives, though they might have done these things without leaving archaeological traces. This pattern shows up in their tool-making too. Neanderthal stone tools are sophisticated, well-made and effective, but they're also conservative. The same basic designs show up across Europe for tens of thousands of years. Very little innovation, very little experimentation. When they found something that worked, they stuck with it. Now, clothing. Did Neanderthals wear clothes? Logic says they must have. You don't survive Ice Age Europe winters without some form of insulation. But clothing doesn't preserve well in the archaeological record. We have no direct evidence of Neanderthal garments. What we do have are stone scrapers showing wear patterns consistent with hide processing. We have bone awls that could have been used to punch holes in leather for sewing. And we have those massive nasal passages that suggest their bodies were working overtime to warm the air they breathed. which might have been less necessary with good clothing. Based on this indirect evidence, most researchers think Neanderthals wore simple garments, probably animal hides draped over the body and tied with sinew, maybe cloaks or capes, possibly foot coverings, but probably not tailored clothing with sleeves and leggings. That kind of complex garment construction seems to be a modern human innovation, possibly one of the advantages that let our ancestors survive in the Arctic, while Neanderthals never made it that far north. And then there were the predators. Because here's something we rarely think about. Neanderthals weren't the only apex predators in Ice Age Europe. They shared the landscape with some of the most formidable carnivores in Earth's history. Cave lions, bigger and more powerful than modern African lions. Cave bears, massive omnivores that could absolutely kill a human if threatened. Cave hyenas, pack hunters with bone-crushing jaws. And wolves, lots of wolves. These weren't background threats. These were daily realities. Archaeological evidence shows that caves used by Neanderthals were sometimes also used by cave bears. Not at the same time, thankfully, but there are sites showing alternating occupation. Neanderthals in summer, bears in winter, or vice versa. Imagine that. Imagine moving into your seasonal camp and having to clear out a bear first, or worrying that a bear might show up while you're sleeping. And yet Neanderthals dealt with this. They defended their camps. They competed successfully with these predators for prey and shelter. They weren't the biggest or strongest predators in their ecosystem, but they might have been the smartest, and that made all the difference. But here's the ultimate irony. Everything that made Neanderthals successful in Ice Age Europe, their robust bodies, their close-range hunting strategies, their small family groups, their intimate knowledge of limited territories, all of these adaptations would become liabilities when the world changed, when new competition arrived. Because 50,000 years ago something unprecedented happened. A new human species, one that had evolved along a different path, one that had developed different survival strategies and different social systems, was about to expand out of Africa and into Europe. And when modern humans met Neanderthals, the strange, tough, isolated lords of Ice Age Europe would face the greatest challenge in their 400,000-year history, a challenge they would ultimately lose. Here's something that would have shocked scientists a century ago. The Neanderthals weren't brutish cavemen stumbling through the Ice Age. They were artists, innovators, caregivers. In some ways, they might have been smarter than the modern humans who eventually replaced them. Let's start with something that completely changes how we think about Neanderthal intelligence. In 2018, researchers in Spain announced a discovery that sent shockwaves through the archaeological community. Deep inside caves that Neanderthals had occupied, they found art. Not art made by modern humans who came later, but art made by Neanderthals themselves, dated to at least 65,000 years ago, which is 20,000 years before modern humans even arrived in Europe. We're talking about red ochre paintings on cave walls, hand stencils made by blowing pigment over a palm pressed against stone, abstract symbols and geometric patterns. This wasn't accidental, this wasn't functional, this was art for art's sake. The creation of something beautiful or meaningful simply because they wanted it to exist. Think about what this means. To create cave art, you need to do more than just survive. You need to have time and resources to spare on non-survival activities. You need to value things beyond food and shelter. You need to be able to think symbolically, to understand that a mark on a wall can represent something else, can mean something. This is the hallmark of abstract reasoning, the kind of thinking we used to believe was unique to modern humans. But the art goes beyond cave paintings. Neanderthal sites across Europe have yielded collections of pigments, ochres and manganese oxides carefully collected, processed and stored. They weren't just randomly smearing mud on things, they were selecting specific colours, grinding them into powder, mixing them with binders to create paint. Some Neanderthal skeletons have been found with traces of pigment on the bones, suggesting they painted their bodies, maybe for ceremonies, maybe for group identification, maybe just because they thought it looked good. They made jewellery, pierced shells and eagle talons, carefully modified to be worn as pendants or beads. These weren't tools, these weren't weapons, these were ornaments, objects whose only purpose was decoration. And here's the really interesting part. The shells they used often came from locations dozens of miles from where they were found. Neanderthals were travelling specifically to collect materials for making jewellery, or they were trading with other groups who had access to these resources. This suggests something profound about their social organisation. They had developed aesthetic preferences, cultural traditions around personal adornment. Different groups might have favoured different styles, creating regional identities that could be recognised through appearance, just like modern humans have always done. But maybe their most impressive achievement was their tool technology. The Mousterian tradition, named after the site in France where it was first identified, represents a quantum leap in human manufacturing. Remember those prepared core techniques I mentioned earlier? Neanderthals perfected them. They developed a method called l'évaloir technique, where they would carefully shape a stone core through multiple stages, then strike it precisely to produce a flake that was already the right shape and size for the intended tool. No modifications needed. This is high-level manufacturing. You have to visualize the final product before you start. You have to understand the properties of different types of stone, how they fracture, what kinds of strikes produce what kinds of flakes. You have to have manual dexterity precise enough to execute a complex series of actions in exactly the right sequence. And you have to be able to teach this process to others, passing the knowledge from generation to generation. The Mousterian toolkit included dozens of specialized implements, scrapers for processing hides, carefully shaped to specific curves that made them efficient for different tasks, points for spears, symmetrical and balanced for accurate throwing, backed knives with one sharp edge and one dulled edge for safe handling, each tool optimized for its specific purpose, each representing accumulated knowledge about what works and what doesn't. And they took care of their tools. Archaeological sites show Neanderthals resharpening worn implements, modifying broken tools to extend their usefulness, recycling old tools to create new ones when raw materials were scarce. This is forward-thinking resource conservation, the opposite of the wasteful, brutish behaviour we once imagined. But here's where Neanderthal intelligence really shines. They buried their dead. Not always, and not in every location, but frequently enough that it's clearly intentional behaviour, not just bodies accidentally covered by sediment. Neanderthal burial sites have been found across their range, from France to Iraq, from Gibraltar to Siberia. And these weren't just holes in the ground. The famous Shanidar cave site in Iraq contained a Neanderthal burial surrounded by flower pollen, suggesting the body had been placed on a bed of flowers. Other sites show bodies deliberately positioned, sometimes in fetal positions, sometimes with limbs carefully arranged. At La Chapelle-aux-Saints in France, an elderly Neanderthal was buried in a pit that had clearly been dug specifically for the purpose. The soil showed signs of having been excavated, the body placed, and the pit refilled. Some burials contain what might be grave goods, though this is hotly debated. stone tools placed near the body, animal bones that might represent food offerings. In one case, what appears to be a covering of red ochre over the corpse. Now we have to be careful about overinterpreting this evidence. Not every object found near a Neanderthal skeleton was necessarily placed there intentionally, but the pattern is clear enough. Neanderthals treated their dead with care and respect. They marked death as significant, as worthy of ritual and ceremony. This tells us something crucial about their minds. They could conceive of death as something other than an animal simply stopping. They understood that a person who died had existed before and would not exist after. They might have had concepts of an afterlife, though we'll never know for sure. At minimum, they valued their group members enough to invest time and energy in proper disposal of the body, rather than just leaving it where it fell. And they cared for their living too. This is one of the most moving discoveries about Neanderthals. Multiple skeletons show evidence of serious injuries or disabilities that healed, meaning the individual survived for years after sustaining them. The Shanidar 1 skeleton, an adult male, had a withered arm, blindness in one eye, and evidence of a severe head injury. Yet he lived to around 40 years old, which was elderly for a Neanderthal. He couldn't have survived without help. Someone fed him, protected him, cared for him through years of disability. Other skeletons show similar patterns, individuals with healed fractures that would have required months of immobility. Elderly individuals with severe arthritis and tooth loss, who would have struggled to keep up with the group or process their own food. They didn't abandon their weak or injured, they kept them alive. This is compassion, this is empathy, this is society. And it gets even more impressive. Neanderthals had medical knowledge. Analysis of their teeth shows traces of plants with medicinal properties, yarrow and chamomile, plants that taste terrible and have no nutritional value but are effective as painkillers and anti-inflammatories. They weren't eating these plants for food. They were using them as medicine. Some Neanderthal skeletons show evidence of dental care, infections that were treated possibly by cleaning wounds or applying medicinal plants directly to painful teeth. But perhaps the most mind-blowing discovery about Neanderthal intelligence involves something called birch bark tar. This is a sticky substance that Neanderthals used as an adhesive to attach stone points to wooden shafts, creating hafted tools. For decades, nobody could figure out how they made it. Birch bark tar doesn't occur naturally. You have to manufacture it. And when modern researchers tried to replicate the process, they discovered it required a complex multi-step procedure. You have to heat birch bark to very specific temperatures, around 340 to 400 degrees Celsius, in an oxygen-poor environment. Too hot and it burns, too cold and nothing happens, too much oxygen and it catches fire. The most efficient method requires building a sophisticated structure, essentially a primitive chemical reactor, with birch bark in a sealed container surrounded by fire, but not directly exposed to flames. The process takes hours and requires constant monitoring. One mistake and you have to start over. Neanderthals were doing this 200,000 years ago. They had developed and mastered a complex chemical engineering process that requires understanding abstract concepts like temperature control and oxygen deprivation. This is high-level technical knowledge, the kind of thing we associate with industrial societies, not Ice Age hunter-gatherers. Yet Neanderthals figured it out, perfected it, and passed the knowledge down through countless generations. Now here's where it gets really interesting. Did they have language? For years, scientists assumed Neanderthals couldn't speak, or at least couldn't speak well. Their skulls seemed to suggest a vocal tract that couldn't produce the full range of sounds modern humans make. But in 2007, researchers made a breakthrough discovery. Neanderthals had the FOXP2 gene, the so-called speech gene that in modern humans is crucial for language development. More specifically, they had the exact same version of FOXP2 that modern humans have. The mutations that separate human FOXP2 from chimpanzee FOXP2, the changes that seem to enable our complex language abilities, were present in Neanderthals too. This strongly suggests they had the genetic capacity for speech, and more recent analysis of Neanderthal skulls and neck bones suggests their vocal tracts could have produced a wide range of sounds, maybe not identical to ours, but more than sufficient for complex spoken language. Think about what this means. Neanderthals living in their Ice Age territories, hunting mammoths through frozen tundra, could have been talking to each other, planning hunts, telling stories, teaching their children not just by demonstration, but by explanation, naming things, making jokes, having arguments about the best places to find flint or which valley had the most reindeer, or whether that injured hunter would survive the winter. They might have had creation myths about where they came from, their own version of the bottleneck story passed down through 700,000 years of oral tradition. They might have had songs, poems, oral histories of great hunters or terrible winters, or the time the ice sheets advanced farther than anyone had ever seen. We'll never know what they said to each other, but the evidence increasingly suggests they could say a lot. But here's the puzzle that has troubled researchers. If Neanderthals were so smart, so capable, so sophisticated, why did they vanish while modern humans survived? Because there is one area where the two species clearly differed: the rate of innovation. Archaeological sites show that Neanderthal technology remained relatively stable for hundreds of thousands of years. The Mousterian tradition, while impressive, didn't change much over enormous spans of time. A Neanderthal toolkit from 200,000 years ago looks pretty similar to one from 40,000 years ago. Modern humans, in contrast, showed explosive technological change. New tool types appear in every few thousand years. Regional variation in styles and techniques. Rapid adaptation to new environments as they spread across the planet. By 40,000 years ago, modern human sites show bone tools, needles for sewing, sophisticated fishing gear, atlatls for throwing spears farther, all innovations absent from Neanderthal sites. This doesn't mean Neanderthals were less intelligent. Their individual cognitive abilities might have been equal to, or even greater than modern humans. Those large brains had to be doing something. But something about their culture, their social organization, or their population structure seems to have limited the rate at which innovation spread and accumulated. Maybe their smaller population size meant fewer inventors. Maybe their more isolated groups meant innovation stayed local instead of spreading widely. Maybe their strong traditions made them more conservative, less likely to experiment with new approaches. Or maybe, and this is increasingly what researchers think, they just had bad luck. They lived in environments where their tried and true methods worked well enough that they didn't need constant innovation. Until suddenly they did. Until modern humans arrived with their rapid-fire technological adaptation and their larger social networks and their slightly different approach to problem-solving, and by then it was too late. But before we get to that final chapter, before we explore what happened when the two species met, we need to understand this. The Neanderthals we're about to encounter weren't inferior primitives about to be swept aside by superior humans. They were sophisticated people with rich cultures, complex technologies, and cognitive abilities that rivaled our own. They made art, They buried their dead with ceremony. They cared for their injured and sick. They had medicine and engineering and possibly language. They were in every meaningful sense human. Just a different kind of human. And what happened to them wasn't inevitable or natural or proof that modern humans were better. It was a tragedy. One we're only now beginning to understand. Picture this. Around 60,000 years ago, a small group of Homo sapiens stands at the edge of the Red Sea, staring across the narrow strait that separates Africa from Arabia. They've decided to leave, not because conditions are terrible at home, but because they're explorers, risk-takers, the kind of people who see a horizon and need to know what's beyond it. They build rafts or wait for low tide and make the crossing. A few hundred people, maybe less, carrying everything their ancestors learned during the bottleneck, every survival skill refined over 100,000 years of near extinction. They don't know it yet, but they're about to meet cousins they haven't seen in 400,000 years. The Neanderthals had been living in Europe and Western Asia for hundreds of thousands of years by this point. They were perfectly adapted to their world. Master hunters who knew every valley, every migration route, every seasonal resource. They'd survived multiple ice ages, population crashes, volcanic eruptions that turned the sky dark for years. They weren't waiting around to be replaced. They were thriving. The first encounters probably happened in the Levant, that narrow strip of land where Africa, Asia, and Europe meet. Modern-day Israel, Lebanon, Syria. Archaeological sites there show something remarkable. Layers of Neanderthal tools, then layers of Homo sapiens tools, then Neanderthal again, then Homo sapiens again. Back and forth for thousands of years. This wasn't one species replacing another in a quick sweep. This was a complicated dance of advance and retreat, competition and coexistence that lasted for millennia. Think about what this means. Two human species separated for 400,000 years of evolution, meeting face to face. They would have looked different, obviously. Neanderthals shorter, more muscular, with those massive brow ridges and barrel chests. Homo sapiens taller, more gracile, with higher foreheads and prominent chins. But not that different. Not like meeting an alien or even another primate. More like meeting someone from a very distant branch of your family tree. Someone who walks upright, uses fire, makes tools, wears clothes, and speaks in a language you don't understand but recognize as language. And here's where the story gets really interesting. We know they didn't just stare at each other across valleys and move on. They met, they interacted, and yes, they had sex. Lots of it, apparently. Because today, if you're of non-African descent, roughly 2 to 4% of your DNA comes from Neanderthals. That's not a tiny trace. That's significant genetic contribution. And it didn't happen through a few isolated encounters. The genetic evidence shows multiple episodes of interbreeding over thousands of years in different locations between different groups. This was sustained contact between two human species who found each other attractive enough to produce viable, fertile offspring. Some of those encounters were probably peaceful, maybe even tender. A young Homo sapiens trader meeting a Neanderthal woman at a resource exchange site, gradually learning to communicate, finding common ground, deciding to build a life together. Their children would have been hybrids, carrying genes from both lineages, probably fitting somewhat awkwardly into both societies, but connecting the two species in profound ways. But let's not romanticize this too much, because while some encounters were peaceful, others definitely weren't. We're talking about two apex predator species competing for the same resources in a world that was getting colder and less forgiving. The climate during this period was brutal. Around 50,000 years ago, the world was sliding into one of the coldest phases of the last ice age. Glaciers were advancing, forests were shrinking, and the hunting grounds that could support large human populations were becoming scarce. Under these conditions, every valley that still had reliable game, every cave site that offered shelter, every freshwater spring became contested territory. And when two groups of humans, Neanderthal and Homo sapiens, showed up at the same resource, somebody had to give way or somebody had to fight. The archaeological evidence for violence between the groups is limited but suggestive. Some Neanderthal remains show trauma patterns consistent with warfare. Projectile injuries, head wounds, and patterns of damage that don't match hunting accidents or interpersonal violence within groups. Similarly, some early Homo sapiens remains from Europe show injuries that could have come from encounters with Neanderthals. This doesn't prove systematic warfare, but it suggests that violent encounters happened, probably more often as competition intensified. Here's where the differences in hunting strategies become crucial. Neanderthals were ambush hunters, masters of close-range killing. They hunted by getting close to large prey, mammoth, woolly rhinos, giant elk, and killing them with thrusting spears at distances of just a few yards. This required incredible courage, phenomenal strength, and intimate knowledge of animal behavior. It also required getting injured. A lot. Neanderthal skeletons show fracture patterns similar to modern rodeo riders, people who spend their lives being thrown around by large, dangerous animals. Homo sapiens, on the other hand, developed different strategies. We were the first humans to systematically use projectile weapons, spear throwers called atlatls, and eventually bows and arrows. This let us kill from a distance. We didn't need to be as strong or as tough as Neanderthals because we weren't getting close enough to get trampled. This wasn't just a minor technological difference. It was a fundamental shift in how humans related to the natural world. Neanderthals were part of the landscape, embedded in it, succeeding through physical prowess and intimate environmental knowledge. Homo sapiens were beginning to stand outside the landscape, manipulating it from a distance, succeeding through technology and innovation. The tool technologies tell the same story. Neanderthal tools were sophisticated, no question. They used that prepared core technique we talked about, producing standardized stone tools that were perfectly adapted to their needs. But their toolkit remained relatively stable over hundreds of thousands of years. They found designs that worked and stuck with them. Homo sapiens tools, by contrast, were constantly evolving. New designs appeared every few thousand years. Blades got longer and thinner, hafting techniques improved, specialized tools for specific tasks proliferated. We were innovating faster, adapting quicker, developing new solutions to old problems at a pace Neanderthals couldn't match. But here's the thing. This doesn't mean Neanderthals were stupid or incapable of innovation. The genetic evidence actually suggests they had larger brains than Homo sapiens. And the archaeological record shows they were perfectly capable of learning from us. At sites where Neanderthal and Homo sapiens remains are found in close proximity, Neanderthal tools start showing Homo sapiens influences. They began making blades similar to ours, using techniques they clearly borrowed from their new neighbors. They even started making personal ornaments, pierced shells and animal teeth worn as jewelry, something they'd never done before we showed up. This suggests cultural exchange was happening. Neanderthals and Homo sapiens weren't just fighting and breeding. They were watching each other, learning from each other, incorporating useful innovations into their own traditions. Some Neanderthal groups that lived near Homo sapiens became more like us technologically, while still maintaining their distinct physical characteristics and core cultural practices. But if Neanderthals could learn from us, why did they lose the competition? Why are they extinct while we inherited the Earth? The answer isn't about individual intelligence or capability. It's about social structure and population dynamics. Homo sapiens had developed something Neanderthals never quite managed: large-scale social networks. Neanderthal groups seem to have been small and relatively isolated. Genetic analysis suggests their effective population size was tiny. Maybe just a few thousand individuals spread across all of Europe and Western Asia. Groups were separated by hundreds of miles, probably maintaining occasional contact, but living independently most of the time. This makes sense given their hunting strategies. You can only support so many ambush hunters in any given territory before you start depleting the prey base. Homo sapiens, by contrast, were networking specialists. Even our earliest populations show evidence of trade networks spanning hundreds or even thousands of miles. Shells from the Mediterranean showing up at sites hundreds of miles inland. Stone from specific quarries being transported across entire regions. Standardized tool designs spreading rapidly across vast territories. This suggests our ancestors maintained regular contact between groups, sharing information, trading goods, and probably exchanging marriage partners to maintain alliances. These larger networks gave us critical advantages. When local resources failed, when game became scarce or climate conditions deteriorated, Homo sapiens groups could rely on support from allied communities. They could migrate to new territories with the help of distant relatives who knew the landscape. They could share information about resource locations, hunting strategies, and environmental changes across hundreds of miles. Neanderthals didn't have these safety nets. When local conditions deteriorated, they were largely on their own. They could move to new territories, but they'd be starting from scratch, needing to learn the landscape, build new hunting strategies, find new shelter sites, all without the kind of detailed local knowledge their ancestors had accumulated over generations. The genetic bottleneck we talked about earlier, the one that had nearly destroyed humanity 900,000 years ago, had taught Homo sapiens an important lesson. Small isolated populations are vulnerable. Survival requires connections, networks, the ability to draw on resources and knowledge from beyond your immediate group. Neanderthals seem to have never learned this lesson, or perhaps their adaptation to European conditions made them less inclined toward the kind of long-distance networking that characterized Homo sapiens. And then the climate got worse. Around 40,000 years ago, as Homo sapiens were flooding into Europe in increasing numbers, the world entered another cold snap. Not as severe as the Great Bottleneck, but bad enough. Glaciers advanced, sea levels dropped, and the productive hunting grounds that had supported both species began shrinking. Under these conditions, the advantages of Homo sapiens' larger social networks became decisive. We could weather local disasters by drawing on regional resources. We could share information about where game was still abundant, which valleys still offered shelter, which territories had been abandoned by failing Neanderthal groups. We could concentrate our populations in the remaining productive areas, while Neanderthals, tied to their traditional territories and lacking our networking capacity, found themselves increasingly isolated in marginal environments. The end, when it came, was gradual. Not a genocidal campaign, but a slow squeeze. Neanderthal populations shrank, became more isolated, began experiencing the kind of genetic problems that come with small population sizes. Meanwhile, Homo sapiens populations grew, expanded, took over the best territories. By 40,000 years ago, Neanderthals were retreating to refuges in Spain, southern France and the Balkans. By 30,000 years ago, they were gone entirely. The last confirmed Neanderthal remains date to around 28,000 years ago in Gibraltar, a rocky peninsula at the southern tip of Spain. A small group, probably no more than a few dozen individuals, holding out in a landscape that was becoming increasingly dominated by Homo sapiens. And then silence. The archaeological record goes dark. The species that had survived for 400,000 years, that had weathered multiple ice ages, that had developed sophisticated tools and complex social practices, was extinct. But not entirely, because that 2 to 4% Neanderthal DNA in modern non-African populations isn't just a genetic curiosity, it's functional. We kept Neanderthal genes that helped us survive. Genes for immune function, skin and hair characteristics, metabolism, and adaptation to cold climates. The Neanderthals lost the competition for territory and resources, but they won a kind of genetic immortality. They live on in us, their DNA still helping billions of people survive in environments around the world. The meeting between Neanderthals and Homo sapiens was the most important encounter between human species in our entire history. It determined which lineage would inherit the earth and which would vanish. But it also showed that the boundary between success and extinction can be surprisingly narrow. Neanderthals weren't inferior. They were sophisticated, intelligent, culturally complex humans who simply lacked one critical advantage at the moment when it mattered most. In a different world, with a different climate, with slightly different timing, it could have been Neanderthals spreading across the globe while Homo sapiens vanished into extinction. But that's not what happened. We survived. They didn't. And the world we inherited was shaped by that fateful meeting thousands of years ago. So here's the question that haunts every archaeologist who's ever held a Neanderthal bone. What happened to them? For over 300,000 years they dominated Europe and Western Asia. They survived multiple ice ages. They thrived in environments that would kill most modern humans in a matter of days. They hunted mammoths, buried their dead, created art and probably told stories around their fires. And then, around 40,000 years ago, they started to disappear. By 30,000 years ago, they were gone completely. Every single Neanderthal on Earth vanished. Now, here's what didn't happen. There wasn't a war. Modern humans didn't sweep across Europe systematically, hunting them down. The archaeological record shows no evidence of large-scale violence between the two species. In fact, the evidence shows the opposite. For at least 10,000 years, maybe longer, we lived alongside each other. We traded with them, learned from them, and yes, had children with them. So this wasn't genocide. It was something much more subtle, much more complex, and in some ways, much more terrifying. Because the Neanderthals didn't vanish in a single catastrophic event. They faded. Gradually, group by group, region by region, over thousands of years. A population here would disappear, then another there, like lights going out across a darkening continent, one by one, until finally the last Neanderthal died somewhere, probably alone, probably not even knowing they were the last. Let's start with the timeline, because understanding when things happened matters enormously. The first modern humans arrived in Europe around 45,000 years ago. The last definitive Neanderthal remains date to about 40,000 years ago, though some disputed sites might push that to 37,000 years ago. That's a minimum of 5,000 years of overlap. 5,000 years during which two human species shared the same continent, hunted the same animals, used the same caves, possibly spoke to each other. For context, 5,000 years ago, The Egyptian pyramids were already ancient. The entire span of recorded human history, from the first Sumerian writing to right now, is only 5,000 years. So this wasn't a brief encounter. This was a long, complex relationship that unfolded over timescales that dwarf our entire civilization. During those millennia, the Neanderthal population was shrinking. Not everywhere at once, not at a steady rate, but declining. Archaeological sites become sparser. The territories they occupied contracted. By 35,000 years ago, they were gone from most of Europe, surviving only in small pockets in southern Spain, isolated valleys in the Balkans, maybe a few other refuges. Then those pockets disappeared too. So what killed them? The honest answer is we don't know for certain. But we have theories, and the most likely explanation is that it wasn't one thing, it was everything. A perfect storm of overlapping crises that individually might have been survivable, but together proved fatal. Let's start with climate, because climate is always part of the story when it comes to human evolution. Remember, Neanderthals evolved in and adapted to Ice Age Europe. They were built for cold. Those massive bodies, enlarged nasal passages, stocky builds, all of it was optimization for frigid environments. But here's the thing about the period when modern humans arrived. The climate wasn't just cold, it was unstable, wildly, catastrophically unstable. Between 50,000 and 30,000 years ago, the Earth's climate was experiencing what scientists call Heinrich events and Dansgaard-Oeschger cycles. Don't worry about the names. What matters is what they did. These were rapid, dramatic climate shifts that could happen within a single human lifetime. Temperatures could plunge by 15 degrees Celsius in just a few decades, then spike back up almost as quickly. Glaciers would advance hundreds of miles, then retreat. Forest would die and be replaced by tundra, then forest would return. Now, Neanderthals had survived ice ages before. They were tough, but this was different. The speed of change was unprecedented. Animal populations couldn't adapt fast enough. The reindeer herds that Neanderthals depended on would vanish from a region in a generation. The forest that provided firewood and plant foods would die off and not return for decades. Even for a species as adaptable as Neanderthals, this was pushing the limits of what was survivable. And here's where population size starts mattering desperately. Remember our discussion of the ancient bottleneck, the metapopulation structure that kept humanity alive by spreading small groups across vast territories. Neanderthals had that same structure, but with a crucial difference. There had always been a smaller population than modern humans. The entire Neanderthal population across all of Europe and Western Asia probably never exceeded 70,000 individuals. Some estimates put it as low as 10,000 during difficult periods. For comparison, by the time modern humans arrived in Europe, our population in Africa alone was probably in the millions. When we expanded out of Africa, we came in waves. Thousands of individuals, then tens of thousands, bringing genetic diversity, bringing new ideas, bringing numbers. This population difference created a fundamental asymmetry. When climate fluctuations wiped out a Neanderthal group, there might not be anyone nearby to repopulate that territory. A valley that had supported Neanderthals for thousands of years goes empty and stays empty. But when a modern human group got hit by disaster, there were more of us to fill the gap. Our metapopulation was larger, more resilient, better buffered against local catastrophes. And those catastrophes were coming fast during this period. A volcanic eruption in Italy around 39,000 years ago, the Campi Flegrei eruption, dumped ash across much of Europe. The climate impact would have been devastating, blocking sunlight, killing vegetation, disrupting animal migrations. Archaeological evidence suggests Neanderthal populations in nearby regions collapsed around this time. Modern human populations in the same areas took a hit too, but recovered within a few centuries. The Neanderthals didn't. But climate is only part of the story. The other part is us, not because we were violent, but because we were competition. Two large predator species can't occupy the same ecological niche indefinitely. Eventually, one of them is going to lose out, and when one of those species has a 10-to-1 population advantage, the outcome is pretty much predetermined. Think about resources. Every calorie a modern human ate was a calorie a Neanderthal didn't get. Every cave we occupied was a cave they couldn't use. Every hunting territory we claimed was territory they lost. And we were better at claiming territory because we had better technology. Not massively better, not science fiction versus Stone Age, but incrementally, crucially better. Modern humans had developed more efficient hunting weapons. We had throwing spears that could kill from a distance, reducing the risk of injury. We had developed ways to make fish hooks and nets, opening up aquatic resources that Neanderthals rarely exploited. We had sewing needles made from bone that allowed us to create fitted clothing, giving us an advantage in cold weather despite our more gracile bodies. Each advantage was small, but they added up. We were also more flexible in what we could eat. Neanderthals were heavily specialized as meat eaters. Analysis of their bones shows they got the vast majority of their calories from animal protein. This made sense in Ice Age Europe, where plant foods were scarce and unreliable. But it also made them vulnerable. When animal populations crashed during climate fluctuations, Neanderthals had limited options. Modern humans ate everything. Meat, yes, but also fish, shellfish, birds, plant roots, nuts, berries, mushrooms. We were dietary generalists, which meant we had fallback options when primary food sources disappeared. When the reindeer herds moved away, Neanderthals might starve. Modern humans would switch to fishing or gathering plants. This flexibility translated directly into population stability. Our groups could survive lean times that would have killed Neanderthal groups. Over generations, this meant modern human populations slowly expanded while Neanderthal populations slowly contracted. Then there's disease. This is the theory that keeps epidemiologists up at night, because we have modern examples of exactly how devastating it can be when isolated populations encounter new pathogens. When Europeans arrived in the Americas, they brought diseases that killed up to 90% of Native American populations. Not through warfare, not through direct violence, but through microbes. Smallpox, measles, typhus, influenza. Diseases that Europeans had evolved some resistance to over thousands of years, but the Native Americans had never encountered. Could the same thing have happened to Neanderthals? We were the same genus, closely related enough to interbreed, but we'd been separated for 600,000 years. Plenty of time for our populations to be carrying different pathogens, different disease loads. When modern humans arrived from Africa, we probably brought tropical diseases that Neanderthals had never been exposed to, and we were coming from much larger populations, which meant we could serve as disease reservoirs in a way that small Neanderthal groups couldn't. The thing about disease is it doesn't leave much archaeological evidence. You can't diagnose smallpox from a 40,000-year-old skeleton. But we know from genetic studies that humans and Neanderthals exchanged more than just genes when we interbred. We also exchanged immune system genes. Sections of Neanderthal DNA that helped fight infections got incorporated into the modern human genome and are still active today. This suggests disease was a significant enough factor that having Neanderthal immune genes provided a survival advantage. But if we were getting immune genes from them, they were getting diseases from us. And here's where population size matters again. Large populations can survive epidemics. You lose 30, 40, even 50% of your population, and it's devastating. But the survivors can rebuild. Small populations can't absorb those losses. A disease outbreak that kills half of a group of 30 people leaves 15 survivors. That's not enough genetic diversity to rebuild. That's a death spiral. And Neanderthal groups were small. Archaeological evidence suggests they lived in bands of 20 to 40 individuals. Probably multiple bands would maintain contact, creating effective breeding populations of maybe 100 to 200 individuals. But that's still tiny. A single epidemic could wipe out an entire regional population. Now let's talk about the absorption theory, because this is where things get really interesting and really complicated. Maybe the Neanderthals didn't go extinct so much as they got absorbed. We know modern humans and Neanderthals interbred. The genetic evidence is overwhelming. Every person of non-African ancestry today carries about 2% Neanderthal DNA. Some people have slightly more, some slightly less, but it's there in all of us. Those genes didn't appear by magic. They came from direct interbreeding between the two species. But here's what the genetic data also tells us. The interbreeding was mostly one-directional. Modern human DNA flowed into Neanderthal populations much more than Neanderthal DNA flowed into modern human populations. Think about what that means in practical terms. It means when our species encountered each other, it was more common for Neanderthal women to have children with modern human men than the reverse. Or if modern human women had children with Neanderthal men, those children were more likely to join modern human groups than Neanderthal groups. Over generations, this creates a genetic tide. Small Neanderthal groups on the edges of their range encountering larger modern human populations. Some interbreeding happens. The children of those unions integrate into modern human groups because those groups are larger, more successful, probably offering better survival prospects. Each generation, a few more Neanderthal genes flow into the modern human population. Each generation, the distinct Neanderthal population gets a little smaller. Eventually you reach a point where the remaining Neanderthals are so few and so isolated that maintaining their distinct identity becomes impossible. Not because anyone is trying to eliminate them, but because simple demographics make absorption inevitable. The last pure Neanderthals probably didn't die of starvation or disease. They probably had children with modern humans because there weren't any other Neanderthals left to mate with. This is supported by archaeological evidence from some of the last Neanderthal sites. The stone tools become less distinctly Neanderthal, more of a hybrid between Neanderthal and modern human techniques. This suggests cultural exchange, probably interbreeding, in those final generations. The boundaries between the two species were blurring, but whether you call this extinction or absorption is almost philosophical. Yes, Neanderthals live on in our DNA. Yes, some of their genes are still active and still providing benefits to their human descendants, but as a distinct species with their own culture, their own identity, their own way of being human, they're gone, and that's still a tragedy. The most likely scenario is that all these factors work together. Climate change stressed Neanderthal populations. Competition with modern humans made it harder for them to recover from those stresses. Diseases transmitted from modern human populations hit them when they were already weakened. Low population numbers made them vulnerable to random demographic catastrophes, and interbreeding with modern humans rather than saving them actually accelerated their disappearance as a distinct group. This is what extinction looks like for an intelligent, adaptable species. Not a dramatic ending, not a final battle, but a slow fade. A gradual narrowing of possibilities as multiple pressures combine, each pressure individually survivable, but together overwhelming. It's death by 1,000 cuts spread across 1,000 years. And here's what really haunts me about the Neanderthal extinction. It could have gone differently. If the climate had been more stable, if modern humans had arrived a few thousand years later or earlier, if disease hadn't been a factor, if any number of variables had been slightly different, Neanderthals might still be here. We might live in a world with two human species, two ways of being human, two different civilizations that evolved from the same bottleneck but took different paths. Instead, they're gone. The caves where they sheltered, empty. The hunting territories they defended for thousands of generations, taken over by our ancestors. The knowledge they accumulated about surviving in Ice Age Europe, mostly lost except for the fragments we preserved through interbreeding. An entire way of being human vanished from the earth, but not completely. Because here's the final twist in the story. We carry them with us. Every person reading this, every person listening, has Neanderthal genes actively working in their body right now. Those genes affect our immune systems, our skin colour, our hair texture, even our susceptibility to certain diseases. The Neanderthals may have vanished as a distinct species, but they live on in us. They're part of what makes us human. And that's where this story takes its strangest turn. But here's the thing about the Neanderthals disappearing from the fossil record. They didn't actually vanish. Not completely. Not in the way we thought for most of the 20th century. Because we're only now discovering the most incredible twist in this entire story. The Neanderthals never really went extinct. They're still here. Inside you, inside me, inside every person reading this whose ancestors came from anywhere outside of sub-Saharan Africa. In 2010, a team of geneticists announced something that shocked the scientific world. They had successfully sequenced the Neanderthal genome, piecing together DNA from fossils tens of thousands of years old, and when they compared that ancient DNA to modern human genomes, they found something nobody expected. Roughly 2% of the DNA in people of European and Asian descent comes directly from Neanderthals. Now, 2% might not sound like much, but think about what that actually means. Your genome contains about 3 billion base pairs, 3 billion letters in the genetic code that makes you human. 2% of that is 60 million base pairs. 60 million pieces of information copied directly from Neanderthal ancestors who lived 40,000 to 60,000 years ago. That's not contamination. That's not error. That's your inheritance from a species we thought had disappeared without a trace. The math tells us something profound about what happened during those overlapping millennia when modern humans and Neanderthals shared territories across Europe and Asia. They didn't just compete. They didn't just fight over resources and hunting grounds. They formed relationships. They had children together. They merged their genetic lineages in ways that permanently altered the course of human evolution. The interbreeding probably happened multiple times in multiple places. The initial meeting in the Middle East around 60,000 years ago when modern humans first left Africa. Then again, as they pushed into Europe and encountered established Neanderthal populations. Maybe dozens of separate encounters over tens of thousands of years, each one leaving genetic traces that accumulated in the expanding modern human population. But here's what makes this even more remarkable. Not all Neanderthal DNA was equally welcome in our genomes. Natural selection was picky about which genes stuck around and which got weeded out. Some Neanderthal genes provided huge advantages to modern humans entering new environments, and those genes swept through populations at lightning speed. Others caused problems, and those got eliminated within a few dozen generations. What remained was a carefully curated collection of Neanderthal genetic variants that made modern humans better adapted to survive in the harsh environments they were colonizing. Let's talk about what we actually inherited. What pieces of Neanderthal biology are still walking around in modern human bodies? First, and most importantly, immune system genes. When modern humans left Africa, they encountered a whole new world of diseases. Bacteria they'd never seen before. Viruses their immune systems had no defenses against. Parasites that had been evolving alongside European and Asian mammals for hundreds of thousands of years. It could have been catastrophic. New populations moving into unfamiliar territory are usually devastated by novel pathogens. But modern humans had a secret weapon. The Neanderthals they were interbreeding with had been living in these environments for 300,000 years. Their immune systems had evolved sophisticated defenses against local diseases. When the two species had children together, those children inherited Neanderthal immune genes that provided instant resistance to diseases that would have killed purely African humans. This wasn't gradual adaptation. This was immediate protection through genetic exchange. Natural selection favored these hybrid individuals intensely. Within just a few generations, certain Neanderthal immune system variants became nearly universal in non-African populations. Today, some of the most important genes that protect you from infections come straight from Neanderthals. Genes that help detect viral proteins, genes that regulate inflammatory responses, genes that coordinate the complex chemical warfare your body wages against invading pathogens. If your ancestors came from Europe or Asia, the Neanderthals are still protecting you every time your immune system fights off an infection. But immunity wasn't all we inherited. Neanderthals also gave us genes affecting skin and hair, which makes perfect sense when you think about it. Modern humans evolved in tropical Africa, where dark skin provides protection from intense UV radiation. But in Ice Age Europe, the situation was reversed. Less sunlight meant less vitamin D production, making lighter skin advantageous. Neanderthals had been adapting to European conditions for 300,000 years. They had already evolved the genetic variants needed for lighter skin and hair. When modern humans interbred with them, those variants got transferred wholesale. Today, many of the genetic variants associated with pale skin and blonde or red hair in European populations come directly from Neanderthals. You're looking at someone with red hair? You're looking at Neanderthal genes expressing themselves in a modern human body. The same thing happened with adaptations to cold climates. Neanderthals gave modern humans genes affecting body fat distribution, metabolism, and the ability to generate body heat efficiently. These traits were crucial for surviving European winters, and natural selection preserved them in populations that remained in cold climates. But the Neanderthal legacy goes deeper than just physical traits. Recent research shows Neanderthal DNA affects things like pain perception, mood disorders, even circadian rhythms. One study found that certain Neanderthal gene variants make people more likely to be morning people rather than night owls. Why? Probably because Ice Age Europe had extremely long winter nights and short summer nights. Being able to adjust your sleep pattern seasonally would have been advantageous. Another study found Neanderthal variants affecting nicotine addiction. Others found connections to skin conditions, blood clotting, and even the shape of your skull. The more researchers look, the more Neanderthal influences they find scattered throughout our genomes. But here's where the story gets complicated. Not all Neanderthal genes were beneficial. Some of the genetic variants we inherited from them are causing problems in modern human populations today. Several Neanderthal gene variants have been linked to increased risk of depression. Others are associated with higher rates of type 2 diabetes, particularly in European populations. Some affect blood clotting in ways that increase stroke risk. One particularly troublesome Neanderthal gene variant increases COVID-19 severity. People who carry 2 copies of this variant are roughly 3 times more likely to require hospitalization if infected. Why would natural selection preserve genes that cause health problems? The answer is that environmental contexts change. A genetic variant that was advantageous in Ice Age Europe might be neutral or even harmful in modern industrialized societies. The Neanderthal genes that helped metabolize high-fat diets from hunting megafauna might contribute to obesity and diabetes when combined with modern processed foods. Immune system variants that protected against Ice Age pathogens might predispose people to autoimmune disorders today. This is evolution in action. We're still living with the consequences of genetic decisions made tens of thousands of years ago under completely different conditions. And here's something that blows my mind. The Neanderthal DNA isn't evenly distributed in modern populations. Different people carry different Neanderthal gene variants. Scientists estimate that while individuals of European or Asian descent carry about 2% Neanderthal DNA, when you look at the entire non-African human population collectively, about 20% of the Neanderthal genome is still floating around in our gene pool. Think about that. Through interbreeding and natural selection, we've preserved about 1/5 of the entire Neanderthal genome distributed across billions of modern humans. The Neanderthals didn't go extinct. They were absorbed, incorporated, made part of us. This completely changes how we understand human evolution. For most of the 20th century, scientists thought human evolution was a simple tree, one species replacing another in a linear progression. Homo erectus gave way to archaic humans, who gave way to Neanderthals in Europe and modern humans in Africa, and then modern humans spread out and replaced everyone else. But that's not what happened. Human evolution was a braided stream, multiple species flowing alongside each other, sometimes diverging, sometimes coming back together and mixing their genes. We're not the pure descendants of African Homo sapiens. We're hybrids, a blend of multiple human lineages that encountered each other as climate and geography shifted over hundreds of thousands of years. The same thing happened with the Denisovans, by the way. Modern populations in Asia and Oceania carry DNA from them too. Some Papua New Guineans have up to 5% Denisovan DNA. Tibetans carry Denisovan gene variants that help them survive at high altitudes. The story keeps getting more complex the more we learn. Recent studies have even found evidence of what scientists call ghost populations, human lineages we haven't discovered yet but whose genetic signatures show up in both Neanderthal and Denisovan genomes, suggesting there were other human species out there, living and interbreeding with our ancestors in ways we're only beginning to understand. This has profound implications for how we think about what it means to be human. For decades we asked, what makes modern humans special? What cognitive or biological traits set us apart from Neanderthals and other archaic humans? But that question assumes a clear boundary between us and them. The genetic evidence shows there was no clear boundary. We merged. The most successful human populations were the ones that incorporated genetic material from multiple sources, blending the best adaptations from different lineages. You are the product of that blending. The reason you're here, the reason humanity survived and thrived, is partly because your ancestors were willing and able to incorporate genetic innovations from closely related species. We succeeded not by staying pure, but by hybridizing. Studying Neanderthal DNA also helps us understand human genetic variation today. Why do different populations look different, have different disease susceptibilities, respond differently to medications? Part of the answer lies in differential Neanderthal ancestry. Populations that stayed in Europe retained different Neanderthal variants than populations that migrated to Asia. This created patterns of genetic diversity that persist today. It's helping medical researchers too. Understanding which diseases are linked to Neanderthal genes helps identify treatment targets. Knowing that certain populations carry specific Neanderthal variants can improve personalized medicine approaches. The Neanderthals are still teaching us things about ourselves 40,000 years after their last pure populations disappeared. And here's maybe the most important revelation. The fact that we carry Neanderthal DNA means they weren't some brutish, inferior species that we outcompeted. They were humans, different from us in some ways, but fundamentally similar in others. Similar enough that when we met, we recognized each other as potential mates, not enemies. Similar enough that our children together were healthy and fertile, capable of having their own children and passing on genes from both lineages. Every discovery we make about Neanderthals reflects back on us. Every sophisticated behavior we find evidence for, every clever adaptation, every artistic achievement, it all reminds us that they were our cousins, our relatives, in the most literal sense, our ancestors. The line between them and us was never as clear as we wanted to believe. We are them, they are us, blended together into something that turned out to be more successful than either species alone. The Neanderthals didn't vanish, they transformed. They became part of the most successful human population in history. Every time you fight off an infection, every time you tan in the summer sun, every time you feel alert in the morning or crave fatty foods in winter, you might be experiencing the echo of Neanderthal biology still operating in your modern human body. They live on in us, and they probably always will. Because here's the thing about what we thought we knew about Neanderthals. Most of it was wrong. Not just slightly off, not just incomplete, but fundamentally embarrassingly wrong. For over 150 years, the scientific consensus painted Neanderthals as primitive brutes, stooped, dim-witted cavemen who barely qualified as human, and we believed it. We built entire museums around that idea, wrote textbooks, created reconstructions showing hairy, slouching creatures with dull eyes and slack jaws. Then in 2010, something changed. A team of scientists led by Svante Pääbo published the first complete Neanderthal genome. They had extracted DNA from 40,000-year-old bones and reconstructed the entire genetic blueprint of an extinct human species. It was like suddenly being handed the owner's manual for a machine we'd been trying to understand by just looking at rusty parts. And what that genome revealed was shocking. Neanderthals weren't distant relatives we'd split from millions of years ago. They were our siblings. Close enough that when modern humans met Neanderthals in Europe and the Middle East, they didn't just compete. They had children together. Children who survived, reproduced, and passed on Neanderthal genes that are still inside you right now. If you're of European or Asian descent, somewhere between 1% and 4% of your DNA came from Neanderthals. That's not contamination. That's not a mistake. That's your heritage. You are part Neanderthal. But the genome told us something even more profound. Neanderthals had the FOXP2 gene, the so-called language gene, the same version modern humans have. This wasn't just suggestive evidence. This was genetic proof that Neanderthals could speak. They had grammar, syntax, the ability to convey complex abstract ideas through verbal communication. Everything we'd thought about their limitations was suddenly up for debate. The floodgates opened. Within a few years, dozens of research teams were racing to extract and sequence DNA from Neanderthal remains across Europe and Asia. Each new genome added detail to the picture, and that picture kept getting more sophisticated, more human, more uncomfortable. We found genes for red hair, genes for pale skin, genes for brown eyes and freckles. Suddenly, Neanderthals weren't just theoretical abstractions. They were people, individuals with distinct appearances, with genetic variants that gave them specific physical traits. Museum reconstruction started changing. The stooped brutes were replaced by upright humans who could walk past you on the street without attracting a second glance. Well, except for being incredibly muscular. That part was real. But here's where the discoveries really exploded. Because DNA was just the beginning. Starting around 2012, archaeologists began applying new technologies to old Neanderthal sites, and they started finding evidence that completely rewrote our understanding of Neanderthal behavior. In Croatia, researchers discovered eagle talons that had been carefully modified by Neanderthals 130,000 years ago, not for tools, for jewellery. The talons showed signs of being strung together, worn as ornaments. This is symbolic behaviour, aesthetic expression, the creation of beauty for beauty's sake. Something we'd insisted only modern humans could do. In Spain, scientists analysed cave paintings using uranium-thorium dating, which measures the age of mineral deposits on the paintings. The results showed that artwork in 3 different Spanish caves was at least 64,000 years old. Modern humans hadn't even arrived in Europe yet. The artists had to be Neanderthals. They were painting geometric shapes, hand stencils, and animal figures, creating art in the darkness of caves, probably by flickering firelight, imagining how they must have looked, how their world must have seemed to artists whose creative impulses were identical to ours. Then came the discoveries that changed everything about how we understood Neanderthal intelligence. In a cave system in France, researchers found something extraordinary. A structure, not a natural formation, not random, a structure. Neanderthals had broken off stalagmites from the cave floor and carefully arranged them in 2 rings, one inside the other. The outer ring was 6 meters across, the inner ring slightly smaller. The construction required moving over 400 stalagmite pieces, weighing a total of about 2 tons, and it was built 176,000 years ago, deep inside the cave, far beyond the reach of natural light. This wasn't a hunting camp, this wasn't a living space. This was something else entirely, something ceremonial, something that required planning, coordination, and abstract purpose. Something that suggests Neanderthals might have had spiritual beliefs, ritual practices, maybe even religion. But the most revolutionary discoveries came from a place nobody had thought to look: underwater. As Ice Age glaciers melted, sea levels rose dramatically, flooding vast areas of coastal land. Those coasts had been prime Neanderthal habitat, warm temperate zones with abundant marine resources. For 150 years we'd been studying Neanderthals only in the places where their sites remained above water: mountainous regions, cave systems, inland valleys. We'd been looking at the refugees, not the successful populations. Starting around 2015, underwater archaeologists began using remote sensing technology to map the submerged coastlines of Ice Age Europe, and they started finding Neanderthal sites, lots of them, in the Mediterranean, off the coast of what's now Greece and Italy, researchers discovered evidence of coastal Neanderthal populations who were exploiting marine resources. They were fishing. They were diving for shells. They were processing seafood using sophisticated techniques that left distinctive tool marks on shell middens, now buried under 30 meters of water. Off the coast of the Channel Islands, archaeologists found Neanderthal sites showing evidence of systematic boat building, not rafts, not accidental ocean crossings, actual boats designed to travel between islands separated by miles of open water. This suggests planning, navigation skills, and technological sophistication we'd never imagined. The scientific consensus began shifting fast. Too fast for textbooks to keep up. Every new discovery pushed Neanderthals further away from the primitive brute stereotype and closer to behavioral parity with modern humans. In 2018, researchers found birch pitch at a Neanderthal site in the Netherlands. Birch pitch is a natural adhesive made by heating birch bark in the absence of oxygen. It requires precise temperature control and understanding of complex chemistry. Modern attempts to recreate Neanderthal birch pitch production show it's actually harder than many industrial processes. They weren't just smart. In some ways, they were doing things we struggle to replicate. Then came the evidence that Neanderthals were practicing medicine. Analysis of calculus, the hardened plaque on Neanderthal teeth, revealed traces of plants with no nutritional value but significant medicinal properties. Yarrow, which is an anti-inflammatory, chamomile, which has sedative and antiseptic qualities. They were deliberately consuming medicinal plants, treating illnesses, caring for their sick. One Neanderthal skeleton from a wreck shows evidence of multiple serious injuries, disabilities that would have made it impossible for him to feed himself or survive alone. Yet he lived years after his injuries. Somebody was feeding him, caring for him, keeping him alive even though he couldn't contribute to the group's survival. That's not animal behavior. That's compassion. That's humanity. By 2020, the transformation was complete. Scientific papers no longer described Neanderthals as primitive. The new consensus acknowledged them as cognitively equivalent to modern humans. Different, yes. Adapted to different environments and facing different challenges, but equally intelligent, equally capable of symbolic thought, equally human in every way that matters. Museum exhibits were redesigned again. Schools updated their curricula. Popular documentaries scrambled to correct decades of misinformation. And researchers began asking a new question. If Neanderthals were so sophisticated, so successful, so well adapted, why did they vanish? The old answers didn't work anymore. We couldn't say they were outcompeted by smarter modern humans. The evidence showed they were just as smart. We couldn't say they failed to adapt. They'd survived in Europe for over 300,000 years through multiple ice ages. We couldn't say they were evolutionary dead ends. Their DNA is literally inside millions of living people. So what happened? Current research suggests the answer is more complex and more tragic than simple competition. It might have been numbers. Even at their peak, Neanderthal populations were small, scattered across Europe in isolated groups. Modern humans arrived with larger populations, faster reproduction rates, better long-distance communication networks. It might have been disease. Modern humans carried African diseases to which Neanderthals had no immunity. When the two species met and interbred, they might have also exchanged pathogens that devastated isolated Neanderthal populations. It might have been climate. The period when Neanderthals disappeared coincides with rapid climate fluctuations. Neanderthals adapted to stable Ice Age conditions might have struggled when the climate started shifting, unpredictably, or it might have been absorption. genetic evidence shows continuous interbreeding between Neanderthals and modern humans for thousands of years. Maybe Neanderthals didn't vanish. Maybe they were gradually absorbed into the larger modern human population, their genes spreading and diluting until distinct Neanderthal populations no longer existed. We might not have killed them. We might have loved them out of existence. But here's what current research really suggests. The answer probably involves all of these factors working together. Small populations facing climate stress, disease, and genetic absorption. Any one of these pressures might have been survivable. All of them together were not. And this raises uncomfortable ethical questions. Questions about how we remember extinct human species. Questions about what we owe to our vanished cousins. Because make no mistake, Neanderthals were people, not animals, not primitive proto-humans. People with language, art, culture, spirituality, medicine. People who loved their children, cared for their elderly, and created beauty in dark caves. People who survived for hundreds of thousands of years before we arrived, and they disappeared. Some researchers argue we should acknowledge what happened as a kind of genocide. Not intentional, not organized, but destructive nonetheless. Others say that's too harsh, that what happened was natural competition and genetic mixing, not extermination. The debate continues. But what's not debatable is that Neanderthals deserve better than the stereotype we gave them. They deserve to be remembered as the sophisticated, successful human species they actually were. And they deserve recognition for their contributions to modern humanity. Those genes you carry aren't contamination, they're gifts. Neanderthal genes help modern humans fight diseases. They influence our immune systems, our skin and hair traits, even our pain tolerance. Some Neanderthal gene variants are associated with increased creativity and problem-solving ability. We didn't just survive while they vanished. We survived in part because of them. Because when our ancestors met Neanderthals, they didn't just compete. They also learned from them, traded with them, loved them, and incorporated their genetic wisdom into our own lineage. The research continues. Every year brings new discoveries. New cave sites revealing unexpected behaviors. New genetic analyses showing previously unknown connections. New technologies allowing us to extract information from increasingly fragmentary remains. Some researchers think we'll eventually find evidence of Neanderthal writing or notation systems. Others believe we'll discover they had more sophisticated navigation and astronomy than we've imagined. And a few think we might find that Neanderthals didn't completely vanish, that isolated populations might have survived longer than we think, perhaps even into historical times. The mystery isn't solved, it's just becoming more interesting, more complex, more human. And maybe that's what Neanderthals teach us about survival. That intelligence alone isn't enough. That adaptation isn't just about individuals, but about populations and networks. That sometimes the line between success and extinction is thinner than we'd like to believe. We survived? They didn't. Not because we were smarter or stronger, but because of small differences in population size, reproductive rate and timing, factors mostly beyond anyone's control, which means our survival might be less about superiority and more about luck, and that's a humbling thought. Every time you look at reconstructed Neanderthal faces in a museum, you're looking at people who were just as human as you, just as intelligent, just as capable of love, art, and wonder. People who face the same existential struggles we still face. How to survive in a changing world, how to maintain community, how to find meaning in existence. They're our strangest cousins, our vanished siblings, our evolutionary might-have-beens, and understanding them helps us understand ourselves. So here we are, at the end of the story. The Neanderthals, those strange, robust, brilliant cousins of ours, are gone. But before we drift off to sleep, let's take a moment to reflect on what we've learned, because the Neanderthal story isn't just about them. It's about us, about what it means to be human, about how fragile and precious our existence really is. Think about everything that made Neanderthals so strange. Those massive barrel chests and stocky builds, perfectly adapted for conserving heat in Ice Age winters. Those enormous nasal passages that could warm air to body temperature before it reached their lungs. Their brains actually larger than ours, packed into skulls with pronounced brow ridges and elongated shapes. They looked different from us, moved differently, even thought differently in some ways. But they were human, undeniably, unmistakably human. And the things they could do. Master hunters who brought down woolly mammoths with nothing but wooden spears and coordination. Artists who ground pigments and painted cave walls in patterns we still don't fully understand. Caregivers who nursed injured companions back to health over months and years, who buried their dead with what looks like genuine grief and ritual. They made jewelry. They appreciated beauty. They had culture. For 400,000 years they were the most successful human species in Europe. They survived ice ages that would have killed modern humans. They adapted to environments so harsh we can barely imagine them. They raised children and told stories and passed knowledge between generations. They were people. But here's the thing that should keep us awake, if we weren't trying to fall asleep. It could have gone differently. There was nothing inevitable about Homo sapiens becoming the dominant species on Earth. Nothing that said modern humans would be the ones to survive while Neanderthals vanished. For tens of thousands of years, both species existed side by side. Both were intelligent, both were adaptable, both had rich cultures and sophisticated technologies. The fact that we're here reflecting on their extinction instead of them reflecting on ours came down to factors we still don't fully understand. Maybe our slightly more efficient hunting strategies, maybe our larger social networks, maybe just luck, the randomness of which populations happened to be in the right place when climate conditions shifted. We survived. They didn't. But in another timeline, another version of history, it could easily have been reversed. What does their extinction teach us? That adaptation has limits. That success in one environment doesn't guarantee success in another. That even the most remarkable survivors, even species that endure for hundreds of thousands of years, can vanish when conditions change too quickly or competition becomes too intense. The Neanderthals did everything right for 400,000 years, and it still wasn't enough. But here's the beautiful, bittersweet part. They didn't completely vanish. Those encounters between our ancestors and theirs 50,000 to 60,000 years ago left permanent marks. 1 to 4% of the DNA in everyone of non-African descent comes from Neanderthals. Their genes help our immune system fight diseases. Their variants influence our hair color, our skin tone, our ability to adapt to different climates. Every time you catch a cold and recover, every time your body successfully fights off an infection, there's a chance you're benefiting from Neanderthal genes refined over hundreds of thousands of years of Ice Age survival. They live on in us. Not as a separate species, but woven into the fabric of modern humanity. We are, in a very real sense, part Neanderthal. Their story is our story. Their survival struggles are part of what made us who we are. So as you drift off to sleep tonight, maybe take a moment to appreciate those strange cousins of ours. The ones who survived ice ages and hunted mammoths and buried their dead with flowers. The ones who are so much like us and yet so different. The ones who almost made it. If you enjoyed this journey into our deep past, do me a favor and hit that like button. Subscribe if you want more history to fall asleep to, and drop a comment letting me know where in the world you're listening from. Are you falling asleep in New York, London, Tokyo? I love hearing from viewers across the globe. Sleep well, descendants of the survivors. Sweet dreams of Ice Age Europe and the relatives we lost along the way.